As you can see, I was very impressed with Kim's haircut, so I decided to copy it for the presentation today. Before I start, I'd just like to acknowledge the co-authors on this work. It's very much an integrated project, this one, where we bring together the science of what might happen with the economics of what might happen. And Ahmed Hafi is the senior agricultural economist on this project. He unfortunately couldn't be here today to present the talk. But he's responsible for the sort of economic thinking that goes into this, and my background's more in the ecological, biological side of things. Lucy Randall's a land use mapper, which is also another fundamental part of what we do. Anyone who doesn't really know all this has been asleep the last couple of days, obviously. This is Pierce's disease in the US, so I won't really dwell on that. But we did focus on the potential impacts on wine grapes in Australia. So as we've seen, Xylella fastidiosa is a very complex disease. It can cause impacts on all sorts of things. We've focused on the potential if we got the strain that causes impacts on grapes. And when we're doing these types of studies, you want to bring together three things, really. One is what are the potential extent of the impacts, and that's really about where this sort of disease might occur. How quickly do these arise? And we need to do that because in the economic modelling that's done, we discount costs. So costs that occur in the future are discounted back to present day. So the types of costs I will show you are all the accumulated costs discounted back to the present day. And then we try and work out what the actual economic costs will be and then aggregate them all up. So they're the component parts. In terms of estimating the potential extent of impact, we considered three sort of habitat suitability models for Xylella. The first one, you would have seen the presentation by Sandy yesterday. He presented the figure down the bottom there. Is based on minimum winter temperatures, so that gives a broad potential distribution of where it might occur. We also considered the work done by Mark Hoddle, where he put together a Climex model. You heard about the Climex model for glassy winged sharpshooter yesterday. He also did a model for Xylella fastidiosa. But what we've decided with that one was, you'll see there's wrong button. There's a lot of areas in through here which, based on the temperatures, would be highly suitable for Xylella fastidiosa, but don't show up on the Climex model for that. And we think that probably, from Mark's paper, it doesn't appear that he considered irrigation for the purposes of Xylella. He certainly did for glassy winged sharpshooter, but it doesn't appear that he did for Xylella. And of course, most of the wine grapes in Australia are grown in irrigated areas, so water restriction is probably not important. And we also ran a climate match model, and it's just a climate matching model that was developed in one of ABARES precursors, where you take records from overseas of where Xylella can occur, and then try and match the climates from those places to Australia. And again, we get some sort of differences, particularly where it's showing up in some of the cooler areas with the climate match model. And there are issues with the climate match model in terms of where you get that data from and where the actual points for the past occurrence occur. We tried to restrict it to the strain that's relevant to grapes. But ultimately, what we decided to go with, because of the uncertainty and because of the issues with these ones, was the basic temperature cutoff as the one to use for this particular study. The other potential restriction on where Xylella fastidiosa can occur, and we've heard from the American system, there's potential issues with where the vectors and alternative host plants occur, and there's strong patterning in parts of California in terms of riparian strips. So we've also considered using maps of riparian strips in Australia, proximity to rivers being one potential restrictor on where the disease might be an issue. You then want to overlay these potential habitat restrictions with the areas where wine grape production occurs. So this is just a map of wine grape production in Australia, or grape production in general. We didn't actually restrict it to just wine grapes, we did grape production in general. As you can see, major areas through here, major areas over in the west. We basically put these maps together with the potential habitat distributions of the disease. So there's lots of uncertainty about the types of impacts that might occur, as we've heard. We don't really know what's going to happen in Australia. So to deal with some of that uncertainty, what we do is run different scenarios. The first scenario is basically that all vineyards in Australia are highly suitable for Xylella. We could have impacts everywhere. The second scenario he considered was a temperature restriction scenario, where we break the areas up into highly suitable areas, partially suitable areas and unsuitable areas. And then we add on top of that another scenario where we suggest that the impacts could be restricted by the temperature plus proximity to the riparian vegetation. So that provides 3 scenarios, and again there are probably many more scenarios you could think of, but that provides 3 scenarios based on history in other parts of the world about where impacts might occur. What that looks like when you summarise it for the Australian grape industry, highly suitable everywhere is obviously highly suitable everywhere. Once you break it down by the temperature restrictions, you still see, wrong button again, you still see that about 75% of wine grape growing is in highly suitable areas, and almost all the remainder is in areas we'd class as partially suitable. When you're restricted by riparian habitat, of course, you get a much, much smaller area of wine grape production being classed as highly suitable. To give you a bit of an idea of the distribution, so this study was all based on areas of wine grape production, the total areas in hectares. To give you a bit of an idea of how that varies across Australia, a lot of these big areas that you see through here are all the areas down through this part of the country. And a reasonable amount over in Western Australia, but in terms of overall area, quite a bit smaller. Just to give you a bit of context, so while our study was based on areas, but just for a bit of context, in terms of number of vineyards, so if you start thinking about social impacts and things, which we didn't do in this particular study, Southwest Australia has lots and lots of small vineyards. So we didn't consider that type of thing in this particular analysis, but in terms of types of social impacts and things, that might be something where you're impacting on a lot more individuals, really. Okay, so by region, what does it look like in terms of suitability type areas? And you can see that it does vary quite a bit across the regions. Some of the regions, nearly the entire region's highly suitable. Other parts of the region, other regions, particularly in the cooler sort of parts of the country, much smaller proportions of the region are actually suitable under scenario 2. When you bring in the riparian restrictions, of course, that drops back down the amount of highly suitable area to much smaller components of each of those areas. In terms of determining how quickly the impacts will occur, main mechanisms for spread, as we've heard, are movement of infected plant material and insect vectors. To determine the rate within farm, we grabbed some work from Alston et al., which was based on the California situation, where they were asked if you remove the sorts of programs they have in place to try and restrict the development of the disease over there, how quickly would it re-emerge as a major issue? Those sort of studies, based on expert elicitation, suggested a fairly rapid increase over about 10 years to then a plateau of incidence, and incidence being the number of newly infected vines per year. And that sort of plateaus after about 10 years. In highly suitable regions, it plateaus at about 10% of vines per year being newly infected and lost. In less suitable regions, about 4% of vines per year. At the landscape scale, it's quite difficult to determine how quickly these impacts will occur. And of course, you see, when we respond to these, we put in place programs that try and restrict spread. We do all sorts of things to do that. We haven't costed any of that sort of thing here. And it's hard to get data on how quickly these things do develop at the landscape scale. There's sort of data out there, but it's often not in the public domain. So it is quite difficult to get an idea of the rates of spread. One thing we looked at was citrus variegated chlorosis in Brazil as an example, a different strain of Xylella fastidiosa, of course. But there is some data published there which shows the change over time in the development of the disease. And from that particular study, you can see that you can estimate a rate of increase of proportion of groves infected over time at a regional scale. And it can happen quite rapidly at the landscape scale. So it can happen rapidly at the landscape scale. It sounds like in Italy with olives, it's happened fairly rapidly at the landscape scale as well. But spread between regions can be slow. So there's evidence of citrus variegated chlorosis, for example, where one region has the disease that spread very rapidly, another region that's not actually that far away doesn't have the disease at all. We haven't dealt with that complexity in this particular study. We've assumed that once it gets to Australia, it might be everywhere and it will develop on all the areas quite rapidly. We've also assumed that the rate in the Alston study largely captures a similar sort of rate to this. So we've based our results basically on the development of the disease based on the Alston study. In terms of the economic impacts on the grape industry, there are a number of them, and you've heard that today. In this particular study, we've focused largely on replacing affected vines with resistant varieties. Now, that won't fully alleviate the impacts of the disease. As we've heard, there's still some sort of susceptibility to the disease. But there are other sorts of activities that can happen, such as clearing vines, clearing host plants around properties, doing vector control, doing all of those sorts of things. They all have their costs. They also have potential environmental costs, as we've heard about restrictions in California. So to simplify this study, we've focused purely on the cost of replacing the vines and assume that that will deal largely with the majority of the impacts. Okay, now in the Australian wine situation, we have a number of wineries out there because of the suppressed prices that are being experienced with wine grapes at the moment, that mean that they're not actually covering their variable costs of production with the money that's coming in for their product at the moment. So to do the sort of economic impacts, we have to break the wine industry up into three components. So we calculate two break-even prices. One is based on the average cost of production divided by the yield. So you can see it's directly proportional to the average cost of production and inversely proportional to the yield. And you don't need to know the details of these formulas here, but I wanted to put those up to show you because the break-even cost does vary quite a lot between regions. And that's the reason it varies between regions, because they have different yields in the different regions in Australia, and their average costs of production actually vary across the different regions in Australia. So this graph here shows you, for 14-15, the average price per tonne received in the different regions. And the bottom of this bar is the break-even price. So we can see in some regions that the break-even price is above the average price received in those regions. And I'll go on to show why that's important in terms of how we've done the calculations in a minute. Another type of property that's out there are those where if they're going to try and deal with the disease, they're going to have to go through this replanting process. So they're going to have to take out the infected vines and they're going to have to replant them with resistant varieties. But there are another group out there where the stream of gross margins, so the money that's coming in for their product over and above their variable costs of production, are not going to be enough to allow them to pay for that replanting. Okay, so it's another group of farmers that are out there that are going to have to deal with this disease. They just can't afford to go through that replanting process. And then, of course, there's the third group who are going to be able to stay in the system by doing their replanting. And that's the second break-even price you can see on the bar here. So there's a whole range of farmers that fall across those. So that creates three types of farms for the purpose of the analysis. You've got those where the gross margins are negative, and we've assumed that they abandon wine grape production. They just drop out of the industry. Now, they won't contribute to the estimate of the costs on the industry because they're not making any money anyway, but they will contribute to the cost on the actual wine industry because you're dropping their production out of the system, and that has flow-on effects through to the wine industry itself. The second group are those that can't afford to replant. They will also drop out of the industry, but in terms of calculating costs then, the costs that we consider for them is the present value of their future stream of gross margins forgone. So if the disease hadn't arrived, they would have stayed in the system, they would have been making money. They're going to drop out, they're not going to make that money. So we calculate that amount. And then we've got those that are going through this transition process, okay? And that transition process also costs money, so we have to calculate the cost of that transition process. To give you an idea of how these are split, we have information from the different regions on the prices received for grapes. And you can see the dark lot here is Group 1, and that was the average, the yellow there. This is Group 2 here. And in this particular region, which is the Hunter Valley, a very small percentage are actually falling into this group where they're receiving high prices. This is just the cumulative value, a cumulative plot of prices received. In other areas, you get a lot more farms that fall into that category of being able to afford to replace their vines. So profitability grouped by region, again, quite variable across the country. So we've got certain areas where profitability is very high, and a lot of people are going to be able to stay in, versus areas where they're not. The other thing we considered is what happens if wine grape prices do actually improve, and there is some evidence that wine grape prices are improving. And so we've also done the figures for 25% higher prices. You don't really need to know the detail of these figures. I mean, of course, people will be able to delve into the detail in the reports, but the key thing here is that it does vary quite a lot across the different regions in Australia. So in terms of the impact on particular regions, it's likely to be quite different. Okay, calculating the costs for those farms that are actually going through the replanting process here, you've got their one-off capital investment as they put the vines in the ground. And then this figure shows this is the money they would have made if they hadn't had to replace their vines, so the vines just stay in the ground. And this is the extra cost then shown below the zero, where they have to put money into establishing these new vines. So they've got the one-off capital cost, and then they've got costs of putting money into establishing these new vines, and it's apparently in the second year where those are the highest to try and get these new vines going. And eventually, as they grow up and they come into production, eventually they reach the point where they're actually producing again, the same as the vines that you've replaced. So you use those figures to calculate the overall cost over time of replacing vines. Then, of course, you have to combine that with the rate of spread of the disease. So as it comes through a particular area, they don't have to do their whole farm at once, but they do it as the disease rolls out across their farm. And this figure, again, don't worry too much about the details, but it just shows how the figures have been calculated. So it's got a farm, the disease arrives according to this pattern, as I mentioned before, and you've got all these different cohorts of trees now being planted to replace the infected trees as the disease rolls out across the farm. And then you've got the absolute costs over time from year zero, shown here, and you've got it then discounted back, so with a 7% discount rate applied. And then you sum all of those together to get the cost at present day. So, the economic impact on the grape industry. Under scenario 1, which is everywhere's at risk, and with current prices, this is scale this axis is in millions, so that's 2,000 million, so that's $2 billion impact on the grape industry in present value terms, if it can go anywhere, down to, and not terribly different with just habitat restriction, with just temperature restriction, a little under $1 billion. If it's restricted to riparian strips as well, and then of course with higher prices you get higher economic impacts because of the foregone costs at those higher prices. The other thing we calculate from this is the lost production. So in the 50th year, eventually, this is the amount of production you would have lost over that 50-year time frame from dealing with the disease, and that's from people dropping out of the industry, the lost production as you transition your vines to the resistant vines. Under scenario 1, we're losing almost 60% of production over that 50-year period, down to about 20% production if the impacts are confined to the riparian strips. At higher prices, of course, less people drop out of the industry. They can actually afford to stay in the industry, so at higher prices you don't have as big an impact on the production. Okay, so less people drop out, so the actual economic impacts on the growers at higher prices are lower. The economic impacts on the less people drop out of the industry. The impact on overall production is much lower. I won't worry about going through the individual regions there because we're running out of time. To take this and then calculate the impacts on the wine industry itself, so as soon as you take stuff out of the grapes out of production, that has then flow-on impacts to the industry itself, to the ability to produce wine. In order to calculate those, what we've done is broken it up into specialised fixed human and capital inputs. So there's very specialised skills involved in making wine and those sorts of things. Okay, the impacts on them are likely to be higher than the impacts on the more movable sorts of inputs. So the general labour that you use to pick grapes and stuff, that's a more movable input. It can move to other parts of the agricultural system, for example. So you use simple supply and demand models to estimate these impacts, but you also deal with those specialised versus general movable impacts by the elasticity you use in your calculations. So the specialised inputs, much less elastic, and they're also much less certain. We don't really understand what the elasticity might be on that. That's why you'll see a range on the graph that I'll show you in a minute. Whereas the general inputs are much more responsive, so much higher elasticity. We've assumed that the grape prices remain unchanged. Australia largely is a price taker in the global market for wine. We've assumed that the wine industry outputs decline by the same percentage as the grape production declines by, and that's just the different cost shares that are actually involved in wine production. So 27% of the cost share comes from the grapes themselves, 43% from the specific inputs that are required to make wine, and 30% from the general inputs. So in terms of the economic impacts on the non-grape components now, you can see that these are higher than the direct impacts on the actual growers themselves. So the direct impacts on the growers are about 2 billion. We're up around 5 billion under scenario 1 here versus 2.5 billion here. And as I said, there's a bit of uncertainty about this because of the elasticity with the specialised supply. We don't really understand what that might be. At 25% higher prices, the impact under scenario 1 actually goes down in this case, because you'll remember that under that scenario we lose less wine grapes. So we don't actually lose as much production of wine grapes, so the actual flow-on effects to the industry are less. Okay? So we have bigger impacts on the growers themselves at higher prices, but less impact on the overall industry. And this is just summing the two figures together. So the overall impact when you put the two together for the growers themselves plus the wine industry impacts, ranging from 7.5 billion under scenario 1 down to about 2.5 billion under scenario 3. And slightly less with the higher prices, because it's actually the wine industry impacts are reduced and they more than offset the other impacts on the industry itself, on the grape growers themselves. That's it. Thank you.